Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. This is the fourth episode in my series to find an effective and efficient mapping from my MacBook keyboard to the various Vice emulators for Commodore 8-bit computers. Last time, we continued building our Vice keyboard map file, working with the numbers and some symbols. We mapped the second row of keys on the MacBook to the Commodore 64. But actually, we didn't quite map the second row. We are missing a few things. First of all of the number keys have additional mappings for colors or special functions. And there are additional graphic characters to be mapped to the minus and equal keys. On the Commodore 64, you can change the text color by pressing either the Control key or the Commodore key while pressing a number. So Control 1 turns the text black, while Commodore 7 would turn the text light blue. In the plan for the mapping, the Commodore Control key is mapped to the Mac's Control key. The keyboard debugger tells us that the key code for the MacBook's Control key is Control_L, and the Commodore's Control key is at row 7, column 2. And if we test that, it doesn't work. If we look at the flags, we see one for 16384. Key is left control on the emulated machine. In other words, we don't just need to map the key, we need to tell Vice that it is the control key. This time it works. I can get all those control colors. We also get the special reverse mode obtained with Control 9 and turned back off with Control 0. Mapping the control key got us 8 colors, but the Commodore 64 supports a whopping 16 colors. You get the remaining 8 by pressing the Commodore key along with the numbers 1 through 8. So let's use the Mac's option key for that. Just like there was a flag for identifying the control key, there is also a flag for identifying the Commodore key. The option key gives us a key code of Alt_L, at least the left option key gives that code, so that makes our mapping to the Commodore key at row 7, column 5 as Alt-L 758192. That means that pressing the left option key along with any of the number keys from 1 to 8 should give us the other 8 colors. Well, that didn't work. Looking at the keyboard debugger shows why. When the control key is used, you see that first the control key is pressed, then the 1 key is pressed. But when the option key is used, we see the option key is pressed as Alt-L, but the next key isn't 1, it's !down. It turns out on the Mac, similar to how the shifted version of keys returns a different key code, the optioned version of keys also returns a new key code. In this case, !down, which is an inverted exclamation point. I didn't know about this up until the time I did this mapping. If you were similarly unaware of this feature of the Mac keyboard, then you're welcome. So let's map the key code !down to the 1 key at row 7, column 0. But what shift flags value should we use? This one looks correct, 2048. Key is combined with CBM for this keysim scan code. That makes our mapping !down 702048. Finishing up our mappings after looking up all the option key codes, we get !down for Commodore 1 or orange, trademark for Commodore 2 or brown, sterling for Commodore 3 or pink, cent for Commodore 4 or dark gray, infinity for Commodore 5 or medium gray, section for Commodore 6 or light green, paragraph for Commodore 7 or light blue, and finally, and filled circ bullet for Commodore 8 or light gray. That does the trick. With that, our color mapping is complete, and Vice can be as colorful as we want, within the limits of the 16 colors selected, seemingly at random, by the Commodore engineers 40 plus years ago. My plan was to map some of the PETSCII graphic characters to the minus and equal keys. Although the related keys on the Commodore 64 have a total of 4 additional graphic symbols, I chose to make the alternate graphic available for each of these symbols the heavy version of the key. So the minus key gets the centered horizontal bar from the 64's shift asterisk, and the equal key gets the heavy cross obtained by the shift plus. We'll map these to the option key combination for each. Option minus gives us a key code of N-, mapped to the asterisk key at row 6, column 1. We use a shift flags of 1 to get the shifted version of that key. Not equal is the key code for option equal, mapped to the plus key at row 5, column 0. Testing this brings back something we saw before when we tried to map the Petsky underscore to the shift minus key. Typing option minus or option equals keeps switching the case of the characters on the screen. Since the option key is mapped to the Commodore key, once again we've created a mapping that sends both the Commodore and shift keys to vice at the same time. And that is the sequence the Commodore 64 uses to switch between its uppercase graphics character set and its lowercase uppercase set. How do I stop that from happening? It turns out that I really can't stop it. At least not, and also keep the option key mapped to the Commodore key. But I can do a bit of a trick. Because the keycodes for keys pressed along with the option are unique, the option press is actually included in the keycode. In fact, I need to add a flag to the mapping to say the Commodore key is pressed as well to get the right key sequence to the emulator. That means I don't actually need to map the option key at all. Now pressing the option and the minus or equal keys gives me the right symbol. It's a reasonable compromise. But just in case there's a program on the 64 that needs the Commodore key pressed by itself, I can map a standalone key for that purpose. I'll choose the left command key for this purpose, which has keycode meta L. Since command key combinations often map to program hotkeys that open menus, switch programs, and so on, the purpose of this mapping is just to be able to tap that key when a single press of the Commodore key is needed. With that, the second row of the MacBook is finally mapped. And we have two transforming keys mapped as well, including the standalone mapping for the Commodore key if needed. Here's all of that added into my forming VKM file. Time to move on. The third row on the MacBook should be easy peasy. A little shuffling of graphic characters on the last three keys, but we figured out how to do that. And the rest is trivially straightforward mapping. The Mac has a tab key. The Commodore 64 does not. The default vice mapping of this key is to the Commodore key, but I'm not a fan of that for two reasons. First, I'm going to reach for the tab regularly because I'm just used to it doing the thing that tab does. Move the cursor to the right some distance, as these tabbed indents from some code demonstrate. Second, other Commodore keyboards do have a tab key. So for the vice emulation of the Commodore 64, I'm going to map the tab key as an alternate spacebar. At least then it will move the cursor forward a bit. The tab key code is capitalized, and the spacebar is at row 7, column 0. So the mapping is tab 740. Shift tab typically moves the cursor back one tab stop, so we'll map that to cursor left, which on the Commodore is shift cursor right. For whatever reason, the key code for shift tab is ISO_left_tab, and the cursor right key is at row 0, column 2, but shifted, so a shift flags of 1 is needed. And now tab is mapped to something reasonable. Mapping each letter on the Commodore keyboard means mapping three things. We'll use Q, the first letter on the keyboard, as our example. First, the normal letter, which uses the lowercase letter as its key code. And we know it will use a shift flags of 0. We just need to look up its keyboard matrix location, in this case row 7, column 6, and mapped. Second is the shifted form, which uses the uppercase letter as its key code, and that means a shift flags of 1. You might be wondering why we can't do this with a shift flags of 8, and map in one line like Q768. But this won't work because the key code for shift Q is different than that for Q, so you can't map both forms to a single key code. Finally, since we are using the option key to act as the Commodore key, we need to look up what the key code is for the option variant of the key, in this case, OE. That gets mapped to the key with the 2048 shift flags to indicate sending the Commodore key with that sequence. Then on to W at row 1, column 1 to get a mapping of lowercase w 110, and shift W as capital W 111. And option W? That's odd. It doesn't have a key code. We could try mapping to U plus 2211. It doesn't work. In fact, nothing seemed to work. I tried other possible forms Vice might recognize. Lowercase u2211, uppercase u2211, 0x2211, 0x1002211, 16885937. I even tried out the 512 flag, which indicates the Alt key is pressed with this key, which can combine with the CBM key flag 2048 to get 2560. Mapping this to both the lower and uppercase W keycodes still achieved nothing. It's time to rethink things. We'll pick this up next time. Thanks for watching. I hope you'll join me next time as we work to break through the option wall and make the keyboard mapping plan a reality.